Hello aspirants, we are going to discuss the important questions regarding the engineering examination, and also this will be a series that will be conducted in the future also. First question is Pascal second as a unit of the correct, it is dynamic viscosity. Let's move on to the second question. Ideal fluid obeys Newton's law of viscosity. Is it correct? No, that is Newtonian fluid. It is frictionless and incompressible. Now the rise of liquid of a specific weight gamma in a capillary tube of radius r is given by, yes, we know that it is 4 sigma cos theta upon gamma d. Therefore it is 2 sigma upon gamma r, since d is equal to 2r. Unit of kinematic viscosity is centimeter square per second. If the dynamic viscosity of a fluid is 0.5 poise and specific gravity is 0.5, then what will be kinematic viscosity? We know that kinematic viscosity is mu upon rho. Therefore from that we can solve it and get 1 as the answer. Surface tension of water increases with decrease in temperature. Yes, it is correct. Surface tension of water increases with decrease in temperature. Surface tension is inversely proportional to the temperature. You can see a basic graph which I have provided here. If a liquid has a greater cohesion than adhesion with the solid, then the liquid in the capillary tube will, yes, it will depress, but it has greater cohesion than adhesion, therefore it will have a convex surface upward. Examine the following 4 statements. Surface tension is due to cohesion only. Is that correct? Yes, that is correct. Capillary is due to both cohesion and adhesion. That is also correct. Therefore the correct option is C. Pressure of 200 kilopascal is equivalent to a head of x meters. We have to find what is x. So we know that P is equal to rho gh. Therefore we are given specific gravity also, and if we divide it by g also, then we will get the answer as 12.82. For a vertical semicircular plate submerged in a homogeneous liquid with its diameter d at free surface, the depth of central pressure will be 3 pi d by 32. I have given the explanation also here. And as we already know that central pressure is the formula as x bar plus ig upon a h bar, or x bar in this case. Therefore after putting all the formulas or putting all the components, we get the required value as 0.589 r, but the options given were in d, therefore we can put it at r as d by 2. Hence we would get an expression as 3 pi d by 32. And for your reference, I've also provided that what is the moment of inertia about the gravitational about the centroidal axis, sin square theta. An open tank, this is a very easy question. 1 meter deep, 50 centimeter depth of oil contains with 50 centimeter depth of soil above it. Therefore they are saying that 0.5 meters this is 1 meter. If we take it as 1 and this as 0.8, therefore 4 or 4 plus centimeter, alright, 4 plus 10, 14. The position of center of pressure on a plane surface immersed vertically in a static mass of fluid is always center of pressure on a position of center of pressure in a plane. Of course it is always below the centroid. Yes. This can also be understood by this. Since we already know that none of these values can be negative, therefore this is plus. This is a given that HCP will be greater than H bar, or at max will come very close to it. a vertical triangular area with the answer should be h by 2, because a triangular area with vertex downward and altitude h has its base lying on the free surface, center of pressure. Again, by using that formula, we can apply h by 3, since it has centroid is h by 3 from top, h by 3 plus bh cube by 36 into area, which is bh by 2 and h by 3. So you will get h by 3 plus h by 6, which is equal to h by 2. This is also given for your reference. The total pressure on a plane surface inclined at an angle theta with the horizontal is equal to PA, since it is given the pressure intensity at centroid of area and areas of plane surface. A vertical rectangular plane surface is submerged in water such that its top and bottom surfaces are 1.5 meter and 6 meter, which is given as such, and 1.5 meter this, and this is 6 meter from the top. Therefore we have this as 4.5, again using the formula which we have discussed till now of center of pressure. We can find out what is the center of pressure. The answer should be 4.2. If you want me to explain it, let's do it. HCP is equal to x bar plus IG sine square theta. Let us assume this as 90. Since it is vertical, it's given that it is a vertical rectangular plane, and A into x bar. Therefore x bar from top is 1.5 plus 2.25. 1.5 plus 2.25, that is 3.75. I'm writing directly 3.75. IG would be B d cube. Okay, IG would be 1, let's assume 1, d cube, even if we did not assume 1, it will cancel out. B d cube 4.5 cube by 12. Area is B into 4.5 into 1 by 3.75. Therefore this gets cancelled out. 3.75 plus 4.5 square divided by 12 to 3.75, it should come out to be 4.2 meter. First of all, it will be 4.5 square, that is 20.25 divided by 3.75 12, and it should come around to be 20.25 divided by 3. It should be around 5 point. This should come out as 0.45, and 0.45 plus 3.75 would give out the answer as 4.2. Therefore answer is 4.2. Center of buoyancy always coincides with the center of gravity. Wrong. Coincides with center of volume of displaced. Yes, correct. Metacentric height for small values of angle of heel is the distance between center of gravity and center of buoyancy. No, incorrect. Center of gravity and metacenter, yes. A floating body is said to be in state of stable equilibrium when its metacentric height is now for floating body and stable equilibrium, metacenter is above the center of gravity. This is stable too, but this is neutral equilibrium. This is stable, but this is not a neutral situation, although in this case you can observe that center of gravity is above metacenter, hence the overturning effect makes this structure unstable. The point in the immersed body through which the resultant pressure of the liquid may be taken is known as center of pressure. There is a definition provided for your reference. If a vessel containing liquid moves downward with a constant acceleration equal to g, then the pressure throughout the liquid mass is atmospheric. This we have to remember, but also I have given a formula for your reference. This has been taken from a source online, so please note that all copyrights reserved to the original owners. I am just providing it for information. but anyway, you can use this P is equal to gamma h into 1 minus Az upon G, where P is the pressure that will be occurring. In this case, Az was G, therefore G upon G 1 minus 1 would have been 0, and therefore if we get P as 0, that means it is the atmospheric pressure. So the correct answer is A. This we have to remember that when a liquid rotates at a constant angular velocity about a vertical axis as a rigid body, the pressure intensity varies as the square of the radial distance. Also note that suggestions are welcome, and if you find any question wrong, please feel free to contact me. I'll change it, and my apologies if any question are wrong. Now, an open cubical tank of 2 meter side is filled with water. Alright, an open cubical tank of 2 meter side is filled with water. If the tank is rotated with an acceleration, moved, or there's a movement due to the acceleration such that the half of the water spills out. Okay, there's half of the water that is spilling out. Let us write with blue. Half of the water spills out. Now what is the acceleration equal to? For this, there's one more concept that you have to learn, that tan theta is equal to A upon G. Now theta, if we see the cross section or the elevation, this is theta. Theta is the angle made by the water with the horizontal. This will be better explained in the next slide. Q or theta is the angle subtended by the water. So this is the water, hence this is the water displaced if we assume that this is the container. Therefore half of the water spills. For tan theta is equal to A by G, which can be observed as H by H also. A is the acceleration and G is the acceleration due to gravity. Since I've already told that this is the amount of water that is expelled or spilled, therefore we know that area of triangle is half breadth into height. This is h, small h, and assuming a width of 1.5 into small h is the area of this triangle, or I beg your pardon, we're not assuming width as b. We have already given that the cube is of dimension h, therefore width is automatically h, and since we want the volume, therefore we multiply with another h. This is like this. So 0.5 h into h into h. This is the amount of water that has expelled or spilled. Therefore this is the spilled amount, and they have already told that it is half of the actual water there was for 0.5 h cube. Therefore we get a relation as h is equal to h is equal to h, and in that case if we put the value over here, we get as A is equal to G. Therefore the correct answer is A equal to G. This was all for my for this video session. We'll continue with further question discussions. I hope you like this video, and I hope to see you soon. Thanks.